Hello, I'm Dr. Harper. This video is an Operations Management BANA3000 Section E01, Spring 2021. And this lecture is week 1. We'll look at definitions. And the definitions, this is just a simple introduction to some of the definitions we'll be using, but it's not all of them. It's to get started, and as we go through the course, we'll introduce other definitions. So let's bring up the lecture. And the workflow is first look at the lecture, do the homework, submit the homework before the due date and time. So this week 1, the summary here is definitions. The text resources is chapter 7 in the text, process design, beginning on page 281. We'll look at 4 different process strategies: the process focus, repetitive focus, product focus, and mass customization. And these are not all of them, but it's a good introduction, and it's a good starting point for this course. Then we'll look at crossover charts, and the crossover charts, I'll look at these in this course because although we see them in this application, the same concept will be used in other applications. So let's get into it. So first of all, here are the 4 strategies, the 4 process strategies. Okay, first one, the process focused. Well, a process focus produces low volume, high variety products within a layout called a job shop. And when you think of a job shop, you can read the examples in the text. But when you think of a job shop, you can think of a mechanic pulling it into the bay and just fixing your car, and everything is right there to focus on that product. Everything is right there, and all the processes are there. It's process focused because everything in that process is going to be right there to satisfy that product. And so the product will go to the processes because the process is focused on the needs. Process-focused operations emphasize efficiency of the processes within operations and usually increases quality because you have everything related to that operation right there in that area. A process-focused operation can also be combined with a repetitive type operation, in which case can be referred to as intermittent processes. In other words, you can have a process focused within a product focused. Okay, and so you can have an intermittent process is that you bring the cars into the mechanic, and all of a sudden it's repetitive, and it's going to be more of a combined with a repetitive type because once it's there, then the operation is repetitive, but then you stop, and then it's intermittent, then another car or another truck comes in or another vehicle comes in. Okay, read different examples in the text. 2, repetitive focus. This produces medium volume, low variety products as a strict definition of the type of operation with low cost and efficiency is usually a design characteristic. In other words, I say medium volume, it's repetitive. Again, repetitive can be part of the process, and the intermittent process could have repetitive in it. So you can have a process focused and repetitive together, and that's called intermittent. But I say medium volume because you do have that idea of, even though it's repetitive, you're changing over to a different product line or a different product, like in a job shop. Low variety products, it's repetitive because you don't have a lot of different products you can make. This is high variety. In other words, this can be made with a lot of different products. Whatever an automobile comes in the mechanic, or a truck or a bus. This is lower variety because it's repetitive. We're doing the same thing over and over again, so you can't do the same thing for everything, for every product. So it's low variety. Repetitive focus characteristics can also design within a module called a cell to create process that combines process focus, repetitive focus into a cellular manufacturing type of operation. Now, cellular manufacturing is different than intermittent processes. Intermittent processes has to do with you're doing repetitive, and then you shift over and you do repetitive again. And so the way you shift is the intermittent part, and there's where you have your processes. But the cellular, on the other hand, cellular says, well, we're dividing this up. And so we have a cell. Within the cell, you might have repetitive, and the repetitive can be put together and into something called a cellular manufacturing. A classic example is an assembly line operation, where you have going down the assembly line. The third is the product focus. It produces high volume, low variety products characterized by long, continuous production runs that are often matched with low cost, standardized product design. So here you have your high volume. You're producing one thing, and that one low variety is just one product, and you're producing that product over and over and over again. But you're focusing on the product itself. And this is like an assembly line, a conveyor belt, and you're just saying, okay, we're making this one product. And it's going to be a long, continuous production run and make a lot of them. Due to the high volume, low cost objectives, a high fixed cost and low variable cost is usually the facility design characteristics. It's very costly to set up, but it's very cheap to run. Mass customization, on page 286, produces low to high volume, low to high variety products with flexibility of features and flexibility of models, a characteristic due to advanced technology and sophisticated product and service design. So mass customization today is where things are coming together. Because of technology, you can have a product focus and a process focus and repetitive focus all together, because technology will allow you to move back and forth. It's much difficult with humans doing the changes, but machines can do the changes very quickly. Okay, the flexible nature of mass customization accommodates strategies such as build to order and postponement or delayed differentiation within the operation strategy. In other words, mass is mass production, customization is specifically designed for a particular customer or a group of customers. So you customize your product. So the high volume has to do with the mass production. The customization has to do with the low variety. And so you can go back and forth and back and forth. Well, the flexible nature, and flexibility is the key here, of mass customization accommodates strategies such as build to order. And build to order is that you get an order coming in and you actually build to whatever that order says. So you're not producing it large numbers. You're producing it customized for that particular order. And sometimes it's build to order, sometimes it's made make to order. You can have different versions of assemble to order, fabricate to order. And a second strategy is something called postponement or delayed differentiation within the operation strategy, where you don't have to have the final product today. You can make the components and wait until you can delay the differentiation of the final product or postpone the final product until it's ready to put it together. And we see that all the time in supply chains. Now, I would suggest that you look at the comparison of process choices on page 288 and consider the list of comparative characteristics on table 7.2 on page 289. And so they go through and you can read each one of them, and that's going to be very informative. Okay, the second thing we're going to be looking at is something called crossover charts, page 289. Example 1 in the text, page 289, has 3 softwares, and they're looking at the cost of adopting software. And so what volume of software which generate reports, what volume of reports, like the number of reports, results in the lowest cost for each software product? Well, notice we have a fixed cost, and let's say it's a fixed annual cost, and a variable cost per each report. So how many reports are you making? And then what's the fixed cost for that particular software? And say you're purchasing the software and implementing the software and then operating it. So the purchasing and implementing is the fixed cost. The operation then becomes the variable cost. Okay, well, notice the structure. The fixed cost goes from 2, 3, 4, so it increases as it goes up from ABC. But the variable cost goes 60, 25, 10. The variable cost goes down as it goes from ABC. So when you have this kind of structure where the fixed cost goes up and the variable cost goes down, or vice versa, that inverse relationship says, well, there's going to be a crossover in there somewhere. Okay, for example, cost. Now, I mentioned lowest cost up here. Cost implies total cost, where the total cost is the fixed cost plus the variable cost times the report volume. For example, for a report, let's make this a little larger. There we go. For example, for a report volume of 1,000 reports, the cost for software A is 200,000, the fixed cost, plus 60, the variable cost, times 1,000 reports. You multiply and add, it becomes 260,000. The cost for B, likewise, is 300,000 fixed cost, plus $25 variable cost times 1,000 is 225K. K meaning 1,000. And the cost for software C is $400,000, plus $10 variable cost times 1,000 report volume. You multiply and add those together and you get 210,000. So that's the idea of cost. So the business question, and this is the definition, but the output of a definition is a business question. What do we want to know? What question do we want to answer? Well, I have two of them here. A business question based on the crossover analysis. How many reports are processed that result in two software products with the same total cost, where total cost is fixed cost plus variable cost? So a crossover, it says, what's the number of reports such that two of these software products will have the same cost? Or a business question based on the cost insight from the crossover analysis. What number of reports will result in each software product with the lowest cost, where the total cost is fixed plus variable cost? So there's two different business questions. Both come from crossover analysis. One is looking at the crossover analysis, and one is looking at the cost implications or insight from that crossover analysis. So in business, this is more than just a mathematical problem. In business, you say you have the math, you're going to have the result here in a minute. What questions am I answering with it? How do I use it? So there's the business part of the quantitative methods. And so in this course, we'll be doing a lot of quantitative methods from the text, and I'll be doing them here, and I'll show you how to work them. So let me show you how to work this particular crossover analysis for the homework. Okay, let's bring this back down so we can see the whole thing. There we go. Okay, so here's the table, the solution table. Software A, software B, software C, here's the fixed cost, and there's a variable cost. So the question is, what's the crossover values? Well, what type of cost between A and B, what is the actual volume such that these two costs are the same? Well, we're going to set these costs together, solve for the volume, and so here's the actual equation. And notice it's 300,000 minus 200,000. So the 300,000 minus 200,000, the fixed cost, divided by 60 minus 25, divided by the variable cost. But notice we take 300 minus 200, and then we go the other way, 60 minus 25. When I do the arithmetic and that equal sign which has a squiggle, that's really approximate. It's approximately 2,857 items. So if our crossover value or volume of reports is 2,857, then the cost of these two are essentially the same. Okay, so therefore, since this has a lower fixed cost, a higher variable cost, software A then will have the lowest cost when the number of reports is less than 2,857. Now between B and C, we're going to have the same thing, 400,000 minus 300,000 right here, divided by 25 minus 10 right here. Do the arithmetic, and that's approximately 6,667. So for software B, if the number of reports is between 2,857 and 6,667, then software B will have the lowest cost. But then software C, since it's the highest fixed cost, you have to make more to see if the lower variable cost will offset the increased fixed cost. Well, that's everything above 6,667, then report software C will have the lowest cost. Well, this is just the results. Where do these come from? Where did that equation come from? Okay. Well, it comes from a simple algebraic manipulation. In other words, set the two costs for two software products, set them equal to one another in software X, which is the number of reports. For example, between A and B here, let X equal the number of reports, and so 200,000 plus 60 times X. So if X is the number of reports, then that equals the cost of software A for X number of reports. For software B, it's 300,000 plus 25X. So that's the cost of software B. And then I just do a solve for X, a little bit of algebra, solving for X. So it's 3,000 minus 200,000, and actually it'll be 60 minus 25, and you divide, and there's where that equation comes from. Now, from Excel, the actual answer from Excel is 2,857.14285714286000000. Well, you don't need all those significant figures, okay? And so I'm going to round this to 2857, and that's why that's approximately equal to 2857, or it's rounded. And that's exactly what I mean up here, rounded. It's rounded to that number because I take these numbers and round it just to the units digit, which is 7. So if it's less than 0.5, I round down. If it's greater than 0.5, I round up. Well, let's see between B and C. Same thing. The B is 3,025, 3,000 plus 25X. C is 400,000 times 10. X. I solve for X, and there's where that equation comes. Again, 6,667. From Excel, it's 666.66666666666670000. If I did that right. But I'm going to round this off, but notice 0.6 here, I'm going to round it to the units digit, but 0.6 here is greater than 0.5. So I'm rounding up to 7, and that's why that's 6667. So rounding in this course will be important. Okay, well, notice this is from Excel. So let's bring up Excel, and let me show you what I've given you to work the homework. So let's bring up the Excel spreadsheet. And here it is. And here's the file. And there's one sheet down here, which is the problem. The other sheet is the solution. Okay, and so I've actually solved it for you. So this problem here, all I did was just type in the values. Here's the example, page 289. I just typed in these values up here in the command bar. You can see all I did was just type in the values. Okay, but then if I want to solve this thing, once you have the problem, a lot of times it's a lot easier to make a copy. Well, you can make a copy here once you've typed all this in. Come down here and highlight the problem spreadsheet on the bar down here. Left click and hold down the control. Left click and hold and drag to the right. And boom, I've actually made a copy of it. And then I can solve it. Okay, well, I'm not going to go through, and the solution is going to be given right here. So what I'm going to be doing here to solve this thing is say, I'm going to highlight this, bring this down 1. I'm going to highlight this, and notice when my fat plus goes to plus with skinny plus with arrows, I can bring that down. So right here is going to be my crossover. So between A and B, it's going to equal, open parenthesis, 3,000, click that, minus 300,000, minus 200,000, click that, in parenthesis, divided by open parenthesis, 60, click that, minus 25, click that, close parenthesis, and notice how it's color-coded. Blue, red, purple, green. Blue, red, purple, green. Blue is a 300,000 minus red, which is a 200,000, divided by purple, which is 60, minus green, which is 25. Press return, and there's my, well, I can make this bigger. And up here under home, you can increase the significant figures there and actually see them all. And there they are. And that's what I put in the lecture notes, and there they are in all its glory. And I can put more zeros, which are very unnecessary, but I could still do it even though it's well, let's do the next one. Equal, open parenthesis, 400,000 minus 300,000, close parenthesis, divided by, open parenthesis, 25 minus 10, close parenthesis. Again, there's my blue, red, purple, green, and there's a little counterclockwise thing going on here. Press return, and there it is. Oh, now the zeros, let's make this bigger. And notice it rounds it off here to 7. See, if I come down, it's rounded to 7. It rounds up for you. So Excel will round it for you until it runs out of significant figures, and then it says, okay, the rest is the zeros. So that's the amount of significant figures it carries. You can count them. I don't know how many there are. You can just count them there. That's how many significant figures Excel carries. Which brings up a very good point. When you calculate anything, especially today you're using Excel, when you calculate anything, use all the significant figures when you calculate. Never round during calculations. Only round the presentation. Like if I'm going to present this number here, I'll present that number as 2857. And I'll represent this number as 6667. But I will never use that number in a calculation. I'll use this number in a calculation because I have all the significant figures. When you start using rounded numbers in calculations, then what happens is there's something we used to call tolerance stack up. It stacks up the tolerance to where all of a sudden your answer can be off. And sometimes if there's a lot of computation, it can be off by quite a bit. Okay. Now, if you can go to the next spreadsheet here, well, that's how you solve it for the homework. But the next solution here, I actually do it. But also over here, I also show you how to actually graph it. Okay, and so I'll let you go through and look at this. I've set these things up here. Actually, there's the software A, and I can just box that in. Here's the software B. I can box that in to highlight it. And software C. Now, to know how I generated this thing, I have the actual calculations up here. See here, I have the calculations. And down here's the crossover chart. You click the crossover chart, and then when you do that, it opens up the chart design in the format. Okay, and so you have the chart design up here, and you click chart design, come over here, select data, and you can see exactly how I did it. You can add it, you can edit it, you can remove it, and this is how I do it. You can edit it, you can see exactly how I put things in. Okay, so there's a name, the solution X's here are these here, the Y values are these here. I say okay. I do the same thing for software B and software C. So I left this in here so you can actually see how to do it and how to graph. There's no graphing in this first homework assignment, but I'm showing it to you so you can look at it. But you can see the crossover, where the software A crosses over with software B right here, somewhere around 2857, right? And then software B crosses over software C somewhere here, 6,667. Okay, that's 667, 2857, so there they are. So you can see what they mean by crossover. Crossover. So you have this crossover kind of a thing. And actually, you see how they cross over. And I'll say crossover. That's not some kind of a symbol. I'm just saying the graph. Okay. Okay. That's all we have for this lecture. Week 1, definitions to get us started. Work the homework. And I hope this helps. And if you have any questions, post them in the Q&A, question and answer in Canvas. And if you want to talk to me personally, have a conversation about something, then you can certainly have office hours Monday, Wednesday, Friday at 7. But any questions about this material, the Q&A for the students in this course, in this topic, should be adequate. So that's all I have for today. I hope this helps.